In January 1934, the British battleship Nelson left Portsmouth for the open sea at 9 knots and went aground on a starboard shoal in a narrow channel due to the unexpected ship's response of swinging her head to starboard, despite the helm being turned to port 15 degrees for the intended course. The reason for this grounding was a typical bank effect. In restricted waters, where the navigable width of a passage is limited, ships are obliged to navigate close to a bare shore or artificial structures such as banks and bridge piers. In such a passage, ships also have to pass by or run in the same direction, while keeping minimum sea room from each other. Under such circumstances, a ship's motion may be largely affected by interference between two ships passing by and going in the same direction in close proximity, and bank effects due to banks, bridge piers and sea-bottom contours. In view of ship handling, ships are exposed to higher risks under such circumstances. Such phenomena affect any ship, regardless of size, when it enters restricted waters. We shall see how a bank effect acts on a ship's steerability. Even in a narrow passage, such as a canal, ships manage to maintain a straight course as they advance on the centre line of passage. By contrast, when a ship's track deviates to either side off the centre line of a passage, the ship moves with its hull as a whole being pulled closer to the bank, while its bow is repelled from the bank. On the contrary, water level rises up the bow because displaced water mass is accumulated in the confined space between the closer bank and the ship's hull. This water level makes a repulsive force to turn the ship's bow outward. This means the generation of a bow outward moment. The bank effect is a phenomenon that causes a bow outward moment and attracts the ship's hull as a whole to the bank due to decreased pressure at the midship area. This attracting force is called suction. Ship handling becomes very tricky due to the deterioration of course stability caused by the bank effect when a ship navigates a narrow channel, as we've illustrated. How should we handle a ship under such conditions? To have a ship run in a straight line on its intended course by offsetting suction and bow outward moment caused by the bank effect, the ship's head has to be kept obliquely to its intended course. As a result of this oblique posture to the advancing direction, extra force and turning moment will be generated on the hull. This extra force will offset suction to the bank. However, to offset bow outward moment, a checking rudder motion toward the bank is still required. This means that the turning moment and the force produced by the proper angle of checking rudder can offset the forces and turning moments generated by bank effect and oblique posture. To prevent contact with the bank at the stern, it is necessary for a ship to steer toward the bank. The ship can then maintain a parallel track to the bank.